Welcome to Archicraft, a bit of architect, your go-to podcast for modern software and solution architecture, enterprise strategies, and AI-powered engineering. Each episode is AI narrated, based on the original blog content by Dima Golodiuk at demongo.com.
You're listening to the 15th episode of the podcast Archicraft. This episode is titled Policy-Based Access Control, Debunking the Myths. In this episode, we explore a definitive architectural deep dive into policy-based access control, a framework designed to address the systemic role explosion and privilege creep inherent in traditional role-based access control. We debunk common myths suggesting that externalized authorization is inherently latent or overly complex, and instead we provide a strategic roadmap for enterprise adoption. We will also examine modern authorization engines like Open Policy Agent and AWS Cedar, illustrating how PBAC decouples policy lifecycles from software releases to enable genuine zero-trust security. Let's get started.
Welcome back to the deep dive. We are shifting gears a bit today. Usually we're all about building things, shipping features, scaling, making the product better.
Right, the shiny stuff.
The shiny stuff, exactly. But today we need to talk about the invisible infrastructure, the part that decides who gets to touch what.
Authorization.
We're talking about the slow, painful death of role-based access control and honestly what actually works to replace it.
It's one of those topics that sounds incredibly dry until you're the person trying to untangle a permission system that's just, grown into a monster.
Or worse, you're explaining to the board why you can't immediately revoke access for a whole region without a full code deployment.
That's a bad meeting to be in.
It is. So we're working off a really definitive analysis by Dmytro Golodiuk. Everyone calls him Dima. The piece is called Policy-Based Access Control, PBAC. Debunking the Myths.
It's a great piece.
And look, if you're a CTO or a lead architect listening, you should know Dima isn't just writing a security tutorial here. This is really a velocity manifesto.
That is the key insight right off the bat. He's not arguing for better security just for security's sake.
No.
He's arguing that our current way of handling permissions, mostly RBAC, is actually a bottleneck. It is slowing down your business.
So let's start there with the status quo, because I think a lot of people are still clinging to RBAC. It feels intuitive.
It does. It maps to the org chart. You have a finance manager, so you create a finance manager role. It answers the question, who are you? Pretty well.
So why is Dima calling it a collapsing architecture? Where's the break?
The break is that the org chart isn't the whole story anymore. In a modern distributed system, who you are is maybe half the equation. The other half is context.
The where, the when, the how.
Exactly. And that leads to the classic role explosion problem.
Right. I've seen this firsthand. You start with a simple marketing manager role. Seems fine.
Simple enough. But then the CISO walks in.
Always the CISO.
And they say, okay, GDPR. They can only view European user data. So fine, you patch it. You create a marketing manager EU role.
A little annoying, but manageable.
But it never stops there. Now the next requirement comes in. They can only view that data during business hours. And only if they're on a corporate managed device.
Oh, no.
And only if the data isn't tagged top secret.
Okay, I see where this is going.
All right.
If I'm sticking to pure RBAC, I can't just have one role. I have to create something called Marketing Manager U Business Hours Corp Device Not Secret.
Precisely. And you do that for every permutation of every job title. You don't end up with 50 roles. You end up with 5,000 roles.
Oh.
And nobody knows what role ID 4092 actually does.
So what happens in the real world? Admins just get lazy, I assume.
They absolutely do. They look at that mess and just say, you know what? Just give him admin so he stops complaining.
And you get privilege creep.
Massive privilege creep because the governance model is too granular to actually govern.
The other side of that coin, and my own teams have done this, is developers just stop waiting. They start hard-coding the logic themselves.
Right. You see it in the pull request.
Yeah.
If user.region.eu and tom.hour18
solves the immediate problem. The feature ships.
It does, but Dima points out it creates three much worse problems. First, audit opacity. Your security team cannot audit compiled code. They have no idea that rule exists.
Second is inconsistency, I'd guess.
Inconsistency, exactly. The billing microservice might have a different idea of EU Then the shipping microservice.
And the third one, this is the velocity killer, release coupling.
That's the big one. If legal changes the definition of business hours, you have to redeploy the entire application just to update that one policy. That's insane.
So this brings us to PBAC, policy-based access control. What's the fundamental architectural shift here? It's not just more roles.
No, it's a completely different philosophy. It's externalized authorization. The core idea is your application code should do one thing: business logic. It should not be making security decisions.
So the app just outsources the decision.
It delegates it. The app just asks a simple question. Can user X do action Y on resource Z? It sends that query to an external brain, and the brain just says permit or deny. The app doesn't know why, it just obeys.
Okay, let's break down the anatomy of that brain. DEMA uses the standard XACML architecture, the 4 Ps. I think walking through these is crucial if you're actually designing this.
Sure. It starts with the PEP, the policy enforcement point.
The bouncer at the club.
Exactly, the bouncer. It's just an interceptor. Could be your API gateway, service mesh, sidecar, whatever. It is intentionally dumb. It just stops traffic and asks for instructions.
And it asks the PDP.
The policy decision point, that's the engine, the brain. It takes the request, it evaluates the rules, and it spits back the decision.
But here's the catch that always gets people. The PDP might need information that isn't in the original request. Like if the rule is about a user's risk score.
Right. The PDP doesn't know the risk score. That's where the PIP comes in, the policy information point.
The researcher.
The researcher. Good analogy. The PDP pauses and asks the PIP, hey, go check our fraud system. What's this user's current risk score? The PIP goes and fetches that extra context.
And finally, the PAP.
The policy administration point. That's just where the rules live. And DEMA is very clear on this. Ideally, it's a Git repository. It's Policies-as-Code.
Okay, so we have the bouncer, the brain, the researcher, and the rulebook. It's a clean separation. But I can already hear the skeptics thinking, you just turned a simple ifelse check into a 4-part distributed system. That sounds complex.
DEMA calls this conservation of complexity. With RBAC, the complexity is hidden in the assignments. It looks simple, but the graph of who has what role is a total nightmare.
A spaghetti mess.
Right. With PBAC, the complexity is visible right there in the policy.
Right.
But it scales linearly. You can write one rule, like allow if user.department equals resource.department.
And that one rule replaces the need to create a role for every single department in the company.
Exactly. You add a new department, you don't touch the authorization system, the rule just works.
Okay, that's the maintainability win. But what about performance? That's the real elephant in the room. If every API call has to make a network hop to some authorization server, that's a latency nightmare.
And you'd be right. If you build it that way, what DEMA calls pattern A, a big central service, you are introducing a network hop for every check. That's often a non-starter.
So what's the fix?
You move the brain closer to the bouncer. This is pattern B, the sidecar model. In Kubernetes, you run the PDP, like Open Policy Agent, in the same pod as your app.
So it's on localhost.
It's on localhost.
Yeah.
There is no network travel. The latency is negligible. It's basically just inter-process communication.
And there's an even faster way, right? Pattern C.
Right, the embedded library model. You literally compile the policy engine into your application binary. It becomes a function call in memory.
A millisecond.
Incredibly fast. But there's a trade-off. You lose the ability to update the engine without redeploying your app. You're coupling them again.
So we have the architecture. Let's talk tools. It feels like there's a bit of a format war brewing here. OPA, Cedar, Zanzibar. How does a team even choose?
It's tricky because they solve slightly different problems. OPA, or Open Policy Agent, is kind of the de facto standard for infrastructure.
Kubernetes, Terraform, that kind of stuff.
Exactly. But it uses a language called Rego.
And the learning curve for Rego is steep.
It's very steep. It's based on Datalog. It's declarative, not imperative, which really throws developers who are used to Python or JavaScript.
So if OPA is the infrastructure king, what's Cedar?
Cedar is the challenger from AWS, but it is open source. It's designed specifically for application authorization. And the syntax is much friendlier. It's almost like SQL. But its superpower is something called formal verification.
Okay, explain that, because that sounds like academic jargon. Why does a business care?
You care because of compliance and safety. With Cedar, you can use automated reasoning to mathematically prove things about your policy. You can ask the engine, prove to me that no possible combination of inputs will ever allow an external user to see top secret data.
Wow. So instead of running 1,000 unit tests and just hoping you caught every edge case?
You get a mathematical proof. If you're in banking, healthcare, government.
Yeah.
That kind of assurance is gold. It's the difference between we think it's secure and we know it's secure.
Okay, and then there's the third one that always comes up with massive scale. Zanzibar.
Right, so Zanzibar isn't really a tool. It's a white paper from Google. It's the design pattern they use for Drive and YouTube.
It's a different model, right? RBAC.
Relationship-based access control. Think about Google Drive. You don't have a role, you have a relationship. I am in a group which owns a folder which contains this document. It's all about traversing a graph.
So if you're building the next Facebook or a huge collaboration tool with nested permissions, Zanzibar's the model you look at.
That's the rule of thumb. If your permissions look like a social graph, go RBAC. If it looks like rules and attributes, you're in OPA or Cedar territory.
All right, so we've picked our engine, we feel good. But Dima brings up what he calls the last mile problem. And this is where I see most implementations fall on their face.
The select star fallacy.
Exactly. The demo always shows a simple API check. Can user fetch order number 123? Yes or no? Easy. But in the real world, a user goes to a dashboard and says, show me all the orders I can see.
And you can't just fetch 1 million orders from your database, send them all to the PDP and have it filter them in memory. You will crash everything. It's horribly inefficient.
So you have to filter at the database, but doesn't that break the whole externalized authorization idea? Now I'm hard-coding SQL filters in my app again.
That is the paradox.
Wow.
And Dima outlines 2 really elegant solutions. The first is partial evaluation.
How does that work?
Instead of asking the PDP, can I see this specific row? You ask it a different question. You ask, what conditions must be true for me to see rows? So the PDP doesn't return a simple yes/no. It returns a logic statement, like region USND department sales. Your application takes that statement and translates it directly into a SQL where clause.
That is very clever. The policy engine is essentially writing the end of your SQL query for you.
Exactly. The logic stays in the policy, but the execution gets pushed down to the database where it belongs.
And the second solution
is to use the database itself. Features like row-level security, RLS, and Postgres. In that model, the PBAC engine just tells the app to set a session variable, like setapp.current2serity equals 123.
And the database has its own internal policies that use that variable.
Right. The database itself enforces the filtering. The application code can literally just run select from orders, and the database magically hides the rows the user isn't allowed to see.
Let's zoom out a bit. We can't talk about modernization without talking about zero trust. How does PDAC fit into that?
It is the engine of zero trust. The whole mantra is never trust, always verify. But Dima pushes it a step further with adaptive authorization.
This is where the PIP, the context gatherer, really starts to shine.
It really does. In the old world, you get a token and you're good for 8 hours. In a PBAC world, every single request can be reevaluated. If you log in from New York and 5 minutes later a request comes from Shanghai using your token, the policy can see that and block it instantly.
But there's still a gap, right? Token revocation. If I fire someone, their oath token is still valid for another hour. They can do a lot of damage.
That's the revocation latency problem. And Dima points to a new standard called CAEP, Continuous Access Evaluation Protocol.
CAE?
It flips the model from pull to push. Instead of waiting for a token to expire, your security tools broadcast events. Your identity provider publishes a user-terminated event. Your application subscribes to that event stream.
And it kills the session in real time.
In near real time. It is immediate. It's the holy grail of session security.
This sounds like a lot of moving parts, though, for someone listening who is sold on the benefits but a little terrified of the implementation. How do you manage it all?
You have to embrace policy-as-code. You treat your authorization logic just like your application code.
So no clicking buttons in some admin UI.
Absolutely not. You write it in an IDE, you commit it to Git, and most importantly, you test it. You write unit tests for your policy. Assert that an admin can access. Assert that an intern cannot access. You catch regressions in your CI pipeline, not in production.
And your audit trail is just your Git history.
It's immutable, which leads to what Dima calls the strategic imperative.
Yeah.
You get velocity because devs stop writing ifalse checks. You get visibility because it's all in one place. And you get versatility.
That versatility point is my favorite part of his whole analysis. The scenario he gives. The board of directors calls, there's a crisis. They ask, can we block all access from country X in the next 5 minutes?
In the old hard-coded world, the answer is no. We need to write code, test it, deploy it, maybe tomorrow.
And that is a resume-generating event for a CTO, not in a good way.
No. But with PBAC, the answer is yes.
Yeah.
You push a policy change, it propagates to the edge, and it's done. You solve a major business problem without touching a single line of application code.
So final advice for the road. Do we just rip and replace everything?
Definitely not. Don't boil the ocean. Dima's advice is to start small. Pick a new greenfield microservice or an internal tool. Pilot PBAC there. Prove the value.
And choose the engine thoughtfully.
Right. OPA for infrastructure, Cedar, or a managed service for your apps. And please think about that last mile database problem from day one because it will bite you.
The perimeter is gone. Identity is the control plane. And it sounds like PBAC is the operating system for that new control plane.
It's about enabling the business to say yes, but to say it safely.
Well, that's a wrap on our deep dive into Dima Golodiac's analysis of PBAC. A lot to chew on there.
Indeed.
I'll leave you with just one final thought. We talked about adaptive authorization, using risk scores for humans, but we're entering a world where more and more of our users are going to be AI agents.
That is the next frontier.
So if an AI agent is performing tasks in your system, does the risk score apply to the AI model itself, to the prompt, to the human who deployed it? And can a policy engine even detect when an agent has started to hallucinate and go rogue?
That is the question that's going to keep architects up at night for the next decade.
Something to mull over. Thanks for listening, and we'll catch you on the next deep dive.
Thanks for tuning in to Archicraft. This episode was generated using AI from Dmytro Golodiac's blog at demongo.com/news. If you enjoyed this episode, follow the show on your favorite platform and share it with fellow architects and engineers. Until next time, build smart, architect with intent.